Hello, I'm Daniele Zanato. I work for LaserPoint, and the subject of this talk is our new blink high-speed sensor, which we believe is the new standard for ultrafast laser measurement. LaserPoint is a company that was founded about 30 years ago, and we are specialized in manufacturing sensor for industrial, medical, and scientific customers to measure any kind of lasers. We have a dedicated product line, which is the subject of the topic today, which is dedicated to ultrafast laser measurement. This is an overview of the current technologies for sensors adapted to measure lasers. We have thermopile, pyroelectric sensor, and photodiodes. Thermopiles are very broadband. They can measure basically wavelength from 200 up to 11,000 nanometers, so basically all kind of laser. They are useful to measure even high power. They can measure even in the kilowatt range, and they are suitable to measure both pulsed and CW. For the pulsed laser, they are measuring the average power. The pyroelectric, they are more or less like the thermopile, but they are not capable of measuring CW laser. They can measure pulsed laser, but up to a certain repetition rate, typically 20 kilohertz. And finally, we have photodiodes that they are very fast. However, they have a low saturation. They cannot measure very high power, and they are not broadband. They respond on a typical range of wavelength depending on the semiconductor they are based on. This is our new blink high-speed sensor, which we have developed expressly for ultra-fast laser. We believe that is a new technology which is unique in the market. In fact, it is a very fast detector. It can measure repetition rate up to 1 megahertz, meaning that it can measure the energy of each single pulse for a laser with a repetition rate up to 1 megahertz. It is a broadband detector, so it can measure from basically 250 to 11,000 nanometer. And it can measure up to 20 watts average power when using a water cooling device. We have developed a specific electronic for this sensor, which is the HSM1000, which is an electronics that can sample up to 500 megasample per second. It connects to the computer via Ethernet card, and it can be triggered. There is a trigger in and a trigger out. Okay. What we can do with a blink HS sensor. First, as I mentioned before, this is a very, very fast sensor. It can measure the energy of each single pulse up to 1 megahertz repetition rate. For example, just to show, this is on the top the acquisition in oscilloscope mode of a laser at 1030 nanometer, 1 megahertz, 3 picoseconds with an average power of 17.5 watts. As you can see, the detector was capable to measure each single pulse. And also it can be used to measure the peak-to-peak stabilities and any kind of statistics regarding the energies. The parameter that the sensor can measure is the pulse energy, which is shown here, the repetition rate, again up to 1 megahertz, the peak power, and also the average power. So one of the main applications for this sensor is to go and study directly the peak-to-peak stability of each single pulse for repetition rate up to 1 megahertz. Another application is the measurement of the transient, the start-on of a laser. When typically a laser is switched on, what we notice is that the very first pulses are not already to the, let's say, value which is specified by the laser. But there is a start-on process which can take some time and which can be very useful to study, especially if you are working with a process that is very sensitive to the energy variation. So you might need to take into account the fact that during the first few milliseconds or microseconds, the laser is not stable, but as you can see here, is emitting with an energy which is increasing in time. Another application for the blink HS is the burst measurement. Nowadays, fiber lasers, especially in the femtoseconds, are capable of generating bursts of pulses. For example, here we have on the top a burst of 5 pulses, 4 pulses with a repetition rate of approximately 40 megahertz. The bursts are emitting at 500 kilohertz, and each peak is about 8 microjoule, and the pulse duration is about 200 femtoseconds. On the bottom here, we have a burst of 15 pulses, again at 14 megahertz, and the repetition rate of each burst is approximately 500 kilohertz. Again, each pulse is about 8 microjoule, and the duration is 200 femtoseconds. We are now developing a method to deconvolute the bursts in such a way that we are able to measure each individual pulse inside the burst. So, to conclude, we believe that our Blink HS is a unique instrument. It is basically the new standard to measure ultrafast laser. As a thermal sensor, it is capable of measuring laser with high power. We can, at the moment, go up to 20 watts, but we are working on detector that will measure higher power. It is a broadband detector, meaning that it can measure from 250 up to 11,000 nanometers, so we can even measure CO2 laser. We can measure both CW and pulse laser with this device. And for pulse laser, I mentioned we are capable of going up to 1 megahertz, meaning we are able to measure the energy of each individual pulse up to 1 megahertz. This is a pretty unique instrument in the market. There is no such an instrument that can both measure high power and go to very high energy laser and also be broadband. Thank you very much for your attention. Again, if you want to contact me, here is my detail, and I'm looking forward for your question. Thank you.